Hi guys, in this video we're going to be looking at how to safely light a portable gas burner for primary school science. Now obviously in primary school science we don't usually have the luxury of a mains gas supply which the high school would normally be able to use for lighting Bunsen burners. So we have to make do with a portable compromise. What you can get to overcome this is a portable cartridge burner with a screw base and a propane and butane gas mixture with a compatible screw top. Safety is paramount with this. Anytime you're lighting any sort of fire in the classroom, it's really important that it's done safely. It's a good idea to know where your fire extinguisher is in case there is something that needs controlled. You should always be able to shut off the gas mixture as well. That's really, really important. If you follow correct procedures, the risk of anything going wrong is minimal. And this is something that you can easily do in a classroom perfectly safely, as long as the kids are sitting down and it's just an observational lesson of you doing a particular experiment. I wouldn't encourage anyone to be doing this with their class actually getting to participate in any of this. So, in order to do this safely, first of all you're going to need safety goggles. There we go, fashionable. And now to connect the burner onto the cartridge, first of all I'm going to make sure that the gas supply is off. So if I turn it that way, that's on. I'm going to make sure it is turned all the way towards the minus so that as soon as I connect it up it's not going to be leaking any gas. So that's off. I've also got the cartridge sitting on a burning plate here. Now I'm going to screw on the cartridge and screw it on so it's just reasonably tight but easy enough to undo if need be. Right, so that is the burner connected. Now if I turn this on too enthusiastically, it does leak quite a lot of gas quite quickly. So I'm going to be quite cautious with how I turn it on. I'm kind of using my ear to hear for how strong the gas flow is. So I'm just going to turn it on. And there's a slight hiss there. And it's lit. Now at the moment we've got a clear yellow flame. Actually really doesn't take a lot of pressure to turn that on at all. So we've got a nice yellow flame there. That's our safety flame. So whenever we're not actually doing something on a high heat, we would have this valve closed, and that's our safety flame there. If I want to do something that requires a higher heat, if I'm using it for a chemical reaction or boiling something or melting something, what I do, on the side of the burner here, you'll notice, and you might remember this from your own high school science, there's a little ring that we can turn. And what that does is it increases the oxygen flow to increase the rate of combustion and aid in more complete combustion. So we've got now a very hard to see blue roaring flame. So you hear this one but you don't necessarily see it. And then we simply turn it back the other way to turn it back to our safety flame. Now there's loads of applications of this. A rule that we have is if we're needing to heat something up, we bring it to the heat source. We don't bring the heat source to it. So this stays flat now, flat and still, and anything that we need to heat up, we would make sure that we've got everything ready, turn it to our blue flame, heat it, and as soon as we're done, it would go back to the safety flame. I would encourage people to do this in primary science. I think it's something that primary science would really benefit from. It opens up a whole range of possible activities that you can do involving chemical reactions. It requires a bit of confidence, it requires a bit of prior knowledge and a bit of prior practice. But it is something that I believe we can do in primary science, and something I think that we should be doing, as long as we follow correct procedures and correct safety guidelines. Cheers.